let's finish off section 6.2. There was a lot going on in it, so I broke it into 3 videos. We're at part 3 now. The rule they start out with is square root of a squared equals a. I know up to this point we've been kind of in our mind, we've been thinking if a squared is under the symbol, under the radical, then we pull it out and we have a. But now we're going a little further to talk about what do we really have as far as values. As far as values go, square root of a squared is going to be absolute value unless it's positive and we know it. If we know for sure a is positive as we're doing a problem, then we know the square root of a squared is a because it was positive, so it doesn't matter. However, if a is negative, then we know a can be a negative. But if we square it, it becomes a positive. And then the square root is positive no matter what. So if a is negative, we have to include that beginning value of negative a, but it's going to become positive when we square it. So we say absolute value of a. It can be plus or minus a. The same for if we don't know. It can be either or. We're not sure. Then we say absolute value because it could be a positive or a negative once we square it. If I start with a negative a, but I square it here, then it's positive. The only time it's a and not in the absolute value, the only time it's just a is if we know for a fact it's a positive to begin with. Okay, so let's do some examples. Example 11, square root of 9x squared. The way we've been doing this is saying, oh sweet, x squared, square root of x squared is x. Square root of 9 is 3. However, for the last part of 6.2, we learned that, yeah, the square root of 9 is 3, but the square root of x squared is absolute value of x because it could be a negative and it would become positive. Now here, square root of x cubed, I won't do this after this time, I'll break it down one more time. Square root of x cubed, how many squareds can we get out? How many perfect squareds can we get out? I can get 1. So I can draw out 1. I leave square root of x as is. And I have x squared. I can pull one of them out, but I have to say it's absolute value because I don't know if my x is positive or a negative. Now here, they go one more step. Now they're saying, hey look, we can have a radical symbol, a radical sign, but inside we can have something that we have to factor out. What you notice with this is it's a perfect square. It's a x minus 3 times a x minus 3. So it's square root of x minus 3 squared. You can think of it that way, or you can just leave it and say, hey, I have 2 of the same thing, I pull one of them out. However, because I don't know what this value is, I have an x, it could be a positive or a negative, then I say absolute value of the whole thing. I can pull one of them out, but I don't know if I'm dealing with a positive or a negative quantity. So absolute value of x minus 3. Example 14. We'll do a few more. We got time. I got a fully charged battery now, and this is our last portion of this section. Now they say, let's have an x cubed minus a 5x squared. So now we've been learning this simple rule. Now we're going back in time to where we have to look for greatest common factor. We have to look for perfect squares, grouping, whatever it takes. We have to use our other rules before we can get to the absolute value idea of drawing out a variable. So I look and I see, is there anything I can pull out of this? Yeah, I can pull out an x squared. When I do, I'm left with x minus 5. So now I have a perfect square here. So I'm going to draw out my x, but I don't know if it's positive or negative. So I have to say absolute value of x. Then there is no perfect square for x minus 5. So I just leave it. I leave it under the radical sign. Anything that's not a perfect square, we just leave as is. Any perfect square we pull out and put inside absolute values unless it's a scenario where they give us a value that we know for sure. And if it's positive, then we can leave out our absolute value brackets. So that was through example 14. I'll try and do a couple more real quickly for you. Example 15. For example 15, they go cubed root. This is a little different scenario because now it matters if it's positive or negative because we have a cube, we have an odd index. When we have an odd index, we can have a negative value. We can have a negative answer. Negative 2 cubed, that's negative 2 times negative 2 times negative 2, which is negative 8. The cubed root of negative 8 is negative 2. There's no way around it. We have an actual value now. You could look, and anytime those are the same, our exponent and our index, we just write what's left. We just write our number. It's a negative 2. If these are the same, they cancel out. I have one more example to work. Cubed root of negative, oh, it's the same thing. This one's the same idea. Now again, you can go ahead and cube negative 5 and get negative 125 and then go backward and say, well, the cube root of negative 125 must be negative 5. Or you can just look and see that these are the same, and whenever they do that, it's easy. When they make the exponent the same as the index, you simply eliminate the radical sign and write your answer. Now, they leave us with this idea of, they tell us if we have an n root, but our variable, or number I guess, but if anything is raised to that root, it is going to be an absolute value if n is even. Because if it's even, we could take any even, means we could take our negative times a negative and end up with a positive. So we could have had a negative value. However, if it's odd, case we had up here, if it's odd, n and n, if that's an odd, then we just have a, because it cancels out, goes away, and it can leave us with a negative value. We'll know if n is odd, we know if a is positive or negative. We know if it's negative, it's going to be negated one more time and leave us with a negative. If it's even, well, then it could have been a negative and become a positive because we'd have a negative times a negative no matter what. So that's a little rule to remember when you're dealing with these perfect squares, square root of a perfect square. Okay, and that finishes off section 6.2. Again, just let me know if you have any questions. I'll do my best to work it out for you, or work them out for you as quickly as possible. All right, take it easy.